Welcome back everyone. I'm Saleha Javed and today we will focus on informed or heuristic searches. So here we have the domain knowledge and this makes our problem little easier and more optimal. For example, we have estimated distances between different states or nodes and we can design our algorithm around it. And now we have guaranteed to find a best solution or a solution in reasonable time. So they are represented in a way, for example, in A star search algorithm, we have a function which defines how our search is going to be conducted. And the goal here is to minimize the total estimated solution cost. The representation is we have an f of n, which is estimated cost of the cheapest solution through node n, which is calculated as g of n, the cost to reach a node n, and h of n, which is estimated cost to get from node n to goal node n. This is the heuristic cost that we add and you will see how it helps us. So let's see an example where we are trying to travel from Malmo to Luleå, and in the table you can see we have different h of n's. So these are real values, real world values, because these can be the air distance from city to city, which is usually the cost we have to bear while traveling. And then we have different numeric values on the edges as well. These are the costs as well which are to be taken from covering for one node and then moving on to the next node. So we add both of these costs and then we compute which path to take. Here you can see our algorithm is little more intelligent and it can decide much better which search path to take in order to achieve the goal. So we have Stockholm, Gothenburg, Östersund, Malmö and Luleå. So let's see how it's going to take its action. As you see, the S node 1, if we calculate and start from Malmö M, which has a cost of 613 to reach to Stockholm, and it has on its edges to go to Gothenburg 272. So in order to calculate how much cost will it be if we take a path to Luleå from Stockholm, we will first add the 613 cost, which is our g of n, and we will add 737, which is the heuristic value to reach Stockholm, and our final cost will be 1350. Likewise, if we try to move to Gothenburg from Malmö, so we will add 272, the edge cost, the path cost, and we will also add 1031 heuristic cost from the table, and our total cost to cover this path will be 1303. So you can see that this is shorter as we have two adjacent nodes from Malmö right now. So we will go to Gothenburg and we will select this path to reach our goal because it has a shorter total cost. Next, if we try to cover the next adjacent states from Gothenburg and the cost is computed in front of you. For example, if we move towards Stockholm from Gothenburg, now this is the path which is not directed from Malmö, this is taken through Gothenburg, then the cost will be 272 Malmö to Gothenburg, 470 Gothenburg to Stockholm, and then the heuristic value to reach Stockholm, and in total it is 1479. The other edges you can see we have cost computed similarly. While reaching to Östersund, we have again 272 Malmö to Gothenburg, Gothenburg to Östersund, and then adding the heuristic value of reaching Östersund 466, we get 1521. And when we move on forward from there to Luleå, from this particular edge, we get the value 1518. But here you see this value 1350 is basically lesser than the path that we take if we go through to Gothenburg and then go back to Stockholm and then move forward. So we choose this particular path. And that is how we decide, we omit the path which has a longer cost, higher cost, and we choose the one which has the minimum cost. And we reach to Luleå from Stockholm. So, we go to Malmö, Stockholm, and then to Luleå. This is how our algorithm decides with A-star algorithm, that how we can reach our goal state with minimum cost and in optimal time. So, if we see advantages of A-star algorithm, it is the best algorithm compared to other search algorithms. You saw in front of you, we were not just discovering nodes, we were intelligently deciding which node should be taken, which path should be taken, and how we can reach our goal node and in optimal time and the best solution. So, it gives us optimal and complete. When we say complete, it means then every time the solution will be reached. There is no confusion, or there is no any such scenario where the solution will not be achieved. So, it is complete. Any algorithm which can end up in infinite loop as depth first search, that is not complete, that is an incomplete algorithm. And A-star can solve very complex problems. For example, we just have an example of 5 cities, we can have 5,000 cities, and still the algorithm will be able to find a solution. The disadvantages, however, are the heuristic needs to be fulfilled by some constraints, and we have to provide the algorithm with real-time heuristic values, and it is pretty complex in terms of computational power as well, memory space as well. You have to compute cost on every single iteration and every single step. So, there is a lot of computation involved, and it requires memory as well. You have to keep all the generated nodes in the memory until you find which one is the smallest one or which one is the minimum cost one, and then you take that particular path. Until then, you have to consume all of the queues that are in the decision list, and you have to keep them in the memory. So, that is not so suitable for large scale problems. But we have some possibilities to improve A-star algorithm as well, which is we can speed it up by following only the n best options. We maybe, because in the previous example you saw we had 4 different paths that could be traversed, and we could choose 2 best and analyze them and ignore the rest and do not compute them. Or we can store typical shortest subpaths between the landmarks in memory. So, here we can improve the memory storage as well. That's it for today. Thank you.